I mean, initially you can pour the contents in from the round bottom flask into a beaker, but later on you can use this kind of conical tube for workup, right? Actually, this comes with a cap, but you're not supposed to use a cap because once you put the cap and shake it, it can build pressure and then it can just flow out, right? So that's the reason. I mean, we should not put the cap. Just use it as it is, right? And then when you mix the contents, use a pipette and then mix in and out the pipette so that it's mixed well. Just like when you want to mix the layers, use a pipette and take in and out so that it is mixed well. And then here the ether layer is on the top and the aqueous layer is on the bottom. So the ether layer is always on the top because it's less dense, so it's going to be on the top. So when you separate those layers, you should give few seconds so that they can separate very well. Then you have to remove the aqueous layer and put it in a beaker. Please do not throw any layers until you know you have the product with you, right? So that's the reason. Please do not throw any of the layers that you separated. So how are you going to separate this layer and put it in another beaker? You just use the pipette, right? First squeeze it and take it all the way down, and then release so that the bottom layer will come into the pipette and then put it in another beaker. So you have to repeat that a couple of times until you remove most of the bottom layer and put it in a separate beaker, right? So now once you remove this layer, you just have the top layer in there, right? So that's the ether layer, and then you'll be adding 3 milliliters of sodium bicarbonate solution, saturated sodium bicarbonate solution. So once you put the sodium bicarbonate solution into the tube, right? Since that is an water solution or aqueous solution, so it is more dense than ether, so it is going to go back into the bottom, right? Again, repeat the same thing. Mix it well with the pipette and let it separate, right? And then remove the bottom layer, put it in the same beaker as you did before, right? Now again, you just have the ether layer in there, right? And then next thing is washing with water. Add 3 milliliters of water into this ether layer. Again, mix it well, right? And then top layer and bottom layer, right? Remove the bottom layer and put it in that beaker, right? So finally, we are having just the ether layer, right? Okay. So now the ether layer, you can put it in a small Erlenmeyer flask, right? And then add the drying agent. So drying agent is anhydrous sodium sulfate, or it could be anhydrous calcium powder. So add a small amount, just like a small spatula, add it to the ether layer in the Erlenmeyer flask, right? So why we are doing all this procedure once the reaction is done? Because we want to get our products out, excluding other stuff, the side products or any inorganic salts and all those things. In this case, first thing is we did the 3 normal HCl wash, or we added 3 normal HCl to get that protonated, right? That oxygen should be protonated. That's the reason we added the HCl, right? And then later on, we added the sodium bicarbonate solution because the HCl is in excess. So we have to get rid of, or we have to neutralize that with sodium bicarbonate solution, right? And then later on, we are using water to remove any sodium bicarbonate solution remaining, right? And at the end, we are using sodium sulfate, that is anhydrous, it's also called drying agent, to remove any trace amount of moisture that is in the ether layer. So all these we are trying to remove one by one, right? So at the end, you'll have ether layer with minimum amount of moisture, right? finally you have ether layer and then this anhydrous sodium sulfate, right, or anhydrous calcium chloride. Once you add the drying agent, give it like a couple of minutes, right? And then so at this point you should remove the ether layer and put it in a new aluminum flask or unused aluminum flask, right? So at this point, you should not let the drying agent go into the ether solution because we want to separate the ether layer and then the solid drying agent, right? So you can either decant into a different aluminum flask or you can pipe it out the liquid into the different aluminum flask, right? So next thing is we have to remove the ether from the product, right? So there could be various methods that we can do. We can use a warm water bath and then put the flask into the warm water, right? So this should be important because if you want to remove the ether, you should use always some kind of water or maybe oil bath sometimes. But in this case, we'll use water bath. If you put the flask directly on the hot plate, what's going to happen? If you put the flask containing ether on the hot plate, what will happen? It will get flamed or it will catch fire. That has happened before. So make sure you use some hot water to remove the ether. Right? Use hot water bath. Just put some water in a beaker and put that on the hot plate. Then place this flask in the hot water because it's flammable. Right? Ether is highly flammable. So that's an important thing you have to remove, right? And then up to what point we have to remove the ether? Okay, so let's say we have like 5 or 10 mils of ether in our flask that we are about to boil off the ether, right? We have to make sure there should be about 1 mil or it's very tiny amount, 1 mil means. So you can just approximate it, lift the flask from the water well and see. If it is very tiny amount, then at that point you can add some hexanes or petroleum ether, right? So that is like crystallizing out or spreading out our product, right? So you will see some kind of white solid or white crystalline solid. So that is our product. We can filter that out using the suction filtration, right? So why we are adding the hexanes into the final solution that we have? Because if you look at this Grignard reagent, so it can also form a byproduct. So that's like what biphenyl. It can be a side product, right? Why it can be a side product? We formed a Grignard reagent, right, in this case, and if you have some bromobenzene, that's a starting reagent, right? So this can, right? So if that attacks that bromobenzene, what will happen? So this will be the product, right? So that's a biphenyl. So it is more soluble in hexanes. That's the reason we add hexanes at the end, and this goes into the liquid part, and your product will be solid. So you can separate those two at that point. That's the reason we precipitate the product with some hexanes, and then this side product will go into the hexanes later, right? And then, so let's say once we have the magnesium, or Grignard reagent formed, right? So if there is some moisture around or water present in a flask, so what will happen? The Grignard reagent is quenched, right? Quenched, we can say it's gone bad. Then what will be the possible product in that case? We can say it's basic, right here. That carbon is basic there, right? And then water is acidic, so it can give a cool down, right? So this will attack that one, right? And then what is this? What will it form? Benzene, right? So it forms benzene. So there is no more Grignard, there is no more reaction. So we'll just get that benzene. So that's the reason we should make sure when we are perform the Grignard, we should follow the strict conditions, strict anti-rust conditions. But once we found the Grignard and then add the benzophenone, and then so we need not worry too much about the moisture at the time, because the reaction is done. The Grignard is quenched with the benzophenone, and then we go further. Right. And then if you have any question, just ask the TS so we can help you.
Next week we have this by
So this first lab report will be the rough draft. So next week you will turn on this rough draft, and we will grade it and give it back to you by maybe the following Monday, and then you can pick it up from the chemistry office, and then you can rewrite that first lab report, and then also you should be giving the second lab report, right? Second and first will be, you should be giving it again, right? So the first lab report is rough draft, right? Okay. I think I have the grading rubric. I have printed it out. I'll get you in after some time, right? Okay. Now we'll take the glassware from the oven, and then make sure. It is hot, right? So handle it with paper towels maybe, and then the magnesium we will crush it and give it to you. You can use it. Okay.